The Juno spacecraft has been revolutionizing our understanding of Jupiter since its arrival in 2016. Its deep scans beneath the clouds have revealed mysteries that challenge everything we thought we knew about the gas giant. Beneath Jupiter's swirling atmosphere lies not just storms, but an enigmatic heart pulsing with powerful forces unlike anything seen before. From terrifying cyclones spinning backwards to a fuzzy core that defies physics, Juno's discoveries are rewriting textbooks. Today we're diving into the most shocking revelations about the largest planet in our solar system. The mysterious central storm discovery. Juno's ultraviolet and microwave instruments uncovered something absolutely terrifying at Jupiter's core, a massive cyclonic storm that shouldn't exist according to our understanding of planetary physics. Unlike the surface storms we can observe from Earth, this central storm spins in the opposite direction to Jupiter's rotation and measures approximately 10,000 kilometers wide, making it larger than Earth itself. In 2017, scientists led by Dr. Scott Bolton from the Southwest Research Institute first reported this bizarre storm that completely defied existing models of Jovian weather patterns and atmospheric dynamics. The storm's presence suggests Jupiter's interior is far more violent and chaotic than anyone previously believed, with turbulent motions that create powerful electromagnetic effects and possibly influence the planet's extraordinary auroras. This discovery opened terrifying new questions about how gas giants maintain their internal heat sources and complex weather systems, forcing scientists to completely rethink everything they thought they knew about planetary atmospheres. The central storm's backwards rotation indicates incredibly complex internal dynamics that researchers are still desperately trying to understand, representing one of the most significant and disturbing findings from Juno's exploration of Jupiter's mysterious depths. The beginning of the mission. Launched on August 5, 2011, the Juno spacecraft embarked on a nearly 5-year journey through the hostile depths of space to reach Jupiter, finally arriving on July 4, 2016. The spacecraft's primary mission was to understand Jupiter's formation, atmospheric composition, massive magnetosphere, and complex gravity field through unprecedented close-range observations. Equipped with sophisticated instruments including the microwave radiometer and Jovian infrared auroral mapper, Juno follows a highly elliptical orbit around Jupiter every 53 days, diving dangerously close through the planet's radiation-filled cloud tops. Mission Commander Scott Bolton and NASA engineering teams spent years developing meticulous protection systems to shield Juno from Jupiter's deadly radiation belts, designing a specialized titanium radiation vault to protect the spacecraft's sensitive electronics from being fried by the intense electromagnetic environment. This groundbreaking mission continues to push the absolute limits of planetary science and space exploration technology, offering humanity's best and closest look yet at the gas giant's mysterious core and incredibly complex magnetic environment. The spacecraft's highly elliptical orbit allows it to approach within just 4,200 kilometers of Jupiter's cloud tops during each perijove pass, collecting detailed measurements and data that were previously completely impossible to obtain. Jupiter is the world of chaos. Jupiter represents the ultimate manifestation of atmospheric chaos in our solar system, with weather patterns so violent and unpredictable, they make Earth's most severe storms look like gentle breezes. The planet's massive atmosphere consists primarily of hydrogen and helium gases, generating vertical wind speeds that regularly exceed 540 kilometers per hour, fast enough to tear apart any spacecraft attempting to enter its atmosphere. Jupiter's cloud layers reveal constantly shifting bands of storms, massive vortexes and lightning strikes that are thousands of times more powerful than anything experienced on Earth. These storm systems create extraordinary geometric patterns and vivid colors visible even through telescopes millions of kilometers away, painting Jupiter's surface in bands of orange, brown, and white. Juno's advanced observations confirmed the presence of massive lightning storms detected by its Jovian energetic particle detector instrument, which identifies highly energetic particles directly linked to these violent and unpredictable weather systems. This incredible atmospheric complexity makes Jupiter not merely a gas giant, but a living laboratory for studying extreme atmospheric dynamics and fundamental physics of fluid turbulence, operating at scales completely impossible to replicate on Earth. The planet's differential rotation means different latitudes rotate at dramatically different speeds, creating powerful shear forces that generate Jupiter's distinctive banded appearance. Io, the volcanic moon. Among Jupiter's 79 confirmed moons, Io stands out as the most volcanically active and geologically violent body anywhere in our solar system, making it a hellish world of constant eruptions and molten chaos. Its scarred surface is covered with hundreds of active volcanoes that continuously spew sulfur compounds and molten lava fountains reaching incredible heights of up to 500 kilometers above the surface. This relentless volcanic fury results from intense tidal heating caused by Jupiter's massive gravitational pull, combined with complex orbital resonances with neighboring moons Europa and Ganymede, creating internal friction that keeps Io's interior molten. Juno's detailed flybys and precise measurements combined with archival data from previous missions like Galileo help scientists understand Io's extreme geological processes and its crucial role in feeding charged particles into Jupiter's deadly magnetosphere. Io's plasma torus, a massive ring of highly ionized gases orbiting around Jupiter, directly influences the planet's radiation environment and provides essential insights into the complex interactions between Jupiter and its satellite system. The moon's sulfur-rich volcanic activity creates a unique and hostile environment, where surface temperatures vary dramatically from extremely cold regions in permanent shadow to areas heated to over 1,800 degrees Celsius by continuous volcanic activity, making Io one of the most geologically dynamic and dangerous worlds. Research on Jupiter's magnetic field. Juno's sophisticated magnetometer instruments have been absolutely crucial in mapping Jupiter's unprecedented magnetic field, which represents the strongest planetary magnetic field in our entire solar system, measuring approximately 14 times more powerful than Earth's protective magnetic shield. This immense magnetic field extends millions of kilometers into space, creating Jupiter's vast magnetosphere that completely dwarfs even the Sun's magnetic influence in the immediate vicinity of the giant planet. Leading scientists, including Dr. Heidi Becker from NASA's Jet Propulsion Laboratory, discovered completely unexpected asymmetries and highly localized regions of intense magnetism during Juno's dangerously close orbital passes through Jupiter's radiation belts. These groundbreaking findings strongly suggest incredibly complex dynamo action occurring deep beneath Jupiter's cloud layers, generated by powerful currents of flowing metallic hydrogen existing under extreme pressure in the planet's mysterious interior regions. Understanding this magnetic environment represents far more than just studying Jupiter. It provides essential insights into planetary magnetic field generation and the protective roles these fields play around worlds throughout the universe. The magnetic field's highly irregular and unpredictable structure clearly indicates that Jupiter's internal dynamics operate through mechanisms far more complex and violent than scientists previously imagined, with profound implications for understanding how massive planets generate and maintain their protective magnetic environments. Juno mission peaks under Jupiter's surface. Juno's precision gravity science investigation revealed one of the most shocking discoveries in planetary science. Jupiter's core is not the compact, solid metallic ball that scientists expected, but instead appears to be a fuzzy, diluted structure extending up to 50% of the planet's total radius. This absolutely astonishing discovery completely challenged and overturned previous models of gas giant planet formation that had been accepted by the scientific community for decades. Detailed gravitational data from the spacecraft indicates that heavy metallic elements are far more spread out throughout Jupiter's interior than anyone predicted, mixing extensively with lighter hydrogen and helium gases in a diffuse, semi-solid core structure. The international research team, led by Dr. Luciano Ies from Sapienza University of Rome, used incredibly precise spacecraft tracking techniques to measure subtle variations in Jupiter's complex gravity field, revealing these hidden internal structures that were completely invisible from external observations. These revolutionary results strongly suggest that Jupiter experienced an extremely violent and chaotic formation history involving massive planetary collisions or prolonged turbulent accretion periods during the early solar system's development. Unveiling this incredible complexity hidden beneath Jupiter's deceptively calm-looking cloud layers provides invaluable scientific clues about gas giant origins, evolution, and the fundamental processes that shape planetary formation throughout the universe, suggesting that giant planets form through far more chaotic and violent processes than previously understood. Jupiter's formation and composition. Jupiter formed approximately 4.5 billion years ago during the earliest phases of our solar system's chaotic development, primarily accumulating vast quantities of hydrogen and helium gases captured directly from the swirling protoplanetary disk surrounding the young sun. Its absolutely massive size, containing over 320 times Earth's total mass, provided sufficient gravitational power to retain these extremely light gases that smaller rocky planets like Earth and Mars could never hope to capture or hold. Juno's advanced spectral observation instruments confirm the presence of trace amounts of water vapor, ammonia, and methane compounds, distributed at varying depths throughout Jupiter's complex atmospheric layers, creating a chemical fingerprint of the planet's formation history. The presence and distribution of these molecular compounds helps scientists reconstruct the primordial materials that Jupiter accumulated during its formation, and provides crucial data about the radial mixing and chemical evolution of compounds over billions of years. Leading research by planetary atmospheric scientist Dr. Lee Fletcher from the University of Leicester enhances sophisticated computer models of Jupiter's atmospheric composition, revealing complex chemical gradients that indicate dynamic upwelling processes and vertical mixing of gases from deep interior regions. Understanding Jupiter's formation process and chemical evolution significantly improves scientific theories about planetary system development and helps predict the potential characteristics and formation mechanisms of gas giant exoplanets orbiting distant stars throughout our galaxy. Jupiter as Earth's protector. Jupiter functions as a massive celestial guardian for Earth and the inner solar system, using its immense gravitational influence to deflect or capture dangerous incoming comets and asteroids that could potentially cause catastrophic impacts on our planet. The planet's enormous magnetosphere and powerful gravitational field significantly reduce the impact rate of potentially hazardous objects in the inner solar system, possibly providing crucial protection that has allowed complex life to evolve and thrive on Earth over billions of years. However, Jupiter's protective role represents a complex double-edged sword. While its gravity shields us from many threats, it can also gravitationally perturb objects and send them on altered trajectories that intersect with Earth's orbital path around the Sun. Comprehensive studies by leading astronomers including Dr. Alan Stern from the Southwest Research Institute emphasize this complicated dual role, examining how Jupiter simultaneously facilitates both planetary protection and potentially dangerous dynamical chaos within our solar system's architecture. Understanding this delicate gravitational balance proves essential for accurately assessing the long-term evolution of Earth's environment and evaluating the likelihood of maintaining stable, life-supporting conditions necessary for biological evolution on planets and other star systems. Jupiter's gravitational influence has fundamentally shaped the orbital architecture of our entire solar system over billions of years, creating complex resonance patterns that affect asteroid and comet trajectories, ultimately influencing the delivery of water and organic materials to inner planets during their formation. The Great Red Spot Mystery. The Great Red Spot represents one of the most iconic and mysterious features in our solar system, a colossal storm system larger than Earth that has been continuously raging for several centuries, yet recently has been mysteriously shrinking at an alarming rate. First definitively observed and documented by astronomers in the 17th century, this massive anticyclonic storm currently spans approximately 16,000 kilometers across and rotates counterclockwise at terrifying speeds exceeding 432 kilometers per hour, creating winds powerful enough to destroy any human-made structure. Juno's sophisticated scientific instruments detected incredibly complex multi-layered cloud structures and intense lightning activity deep within the storm system, providing revolutionary new insights into the energy sources and physical mechanisms that have maintained this enormous weather phenomenon for hundreds of years. Leading researchers, including Dr. Heidi Becker from NASA's Jet Propulsion Laboratory, actively study the complex atmospheric dynamics driving the Great Red Spots concerning shrinkage and investigate potential changes in Jupiter's atmospheric composition or internal energy flow patterns. The storm exemplifies the most powerful and persistent meteorological phenomena known to science, challenging our fundamental understanding of fluid mechanics and atmospheric physics operating on truly planetary scales. Recent detailed observations suggest the Great Red Spot may be gradually losing both its distinctive reddish coloration and its well-defined structural boundaries, raising serious scientific questions about whether this iconic feature will eventually disappear entirely, fundamentally altering Jupiter's appearance forever. Jupiter's rings and lesser moons. Jupiter possesses a surprisingly complex but faint ring system that was first discovered in 1979 by the Voyager 1 spacecraft during its historic flyby, revealing a delicate structure composed primarily of microscopic, dust-sized particles continuously supplied by meteoroid impacts on the planet's small inner moons. These rings, while dramatically less spectacular than Saturn's magnificent and well-known ring system, remain incredibly thin and faint, but play a surprisingly important role in Jupiter's complex magnetospheric environment and particle dynamics. Juno's detailed observations, combined with data from earlier exploratory missions, have identified 4 distinct main ring components and dozens of small, irregularly shaped moons existing within Jupiter's intense radiation-filled magnetosphere. Among these lesser-known moons, Amalthea and Thebes serve as primary dust contributors to the ring system through continuous bombardment by high-velocity micrometeorites that blast material from their surfaces into space. Understanding these smaller celestial bodies and their dynamic ring interactions offers valuable scientific clues about Jupiter's long-term evolution and the fundamental physical processes that shape planetary ring systems throughout our solar system and beyond. The ring particles undergo continuous replenishment cycles through ongoing impacts on the small moons, creating a dynamic equilibrium system where material is constantly being added through collisions while simultaneously being lost through various gravitational and electromagnetic processes, providing crucial insights into the complex gravitational interactions governing ring systems around giant planets. That's the incredible story of Juno's journey deep beneath Jupiter's clouds, uncovering mysteries that force us to completely rethink our understanding of the giant planet. What surprised you the most about these terrifying discoveries? Let us know in the comments below. If you enjoyed diving into Jupiter's darkest secrets like this video, share it with fellow space enthusiasts, and don't forget to subscribe to Sci and Y for more amazing space exploration stories. Until next time, keep looking up. Voyager 1 is a breathtaking testament to human ingenuity and curiosity. Launched in 1977, this remarkably small spacecraft has traversed the vast reaches of the solar system and beyond, venturing where no human-made object has gone before, into interstellar space. As it now drifts deeper into the unknown, Voyager 1 continues to send back invaluable data about the cosmic environment beyond our sun's influence. Recent observations hint at phenomena that both challenge and confirm fundamental aspects of astrophysics, revealing mysteries that hold profound implications for our understanding of the universe. The birth of a star sailor. In the early 1970s, the Voyager program was conceived as a bold mission to explore the outer planets with unprecedented detail. The Voyager 1 spacecraft, roughly the size of a small car, was designed for durability and autonomy, equipped with a golden record, an interstellar message recording the diverse sounds and images of Earth. Directed by Dr. Ed Stone at NASA's Jet Propulsion Laboratory, the mission successfully navigated the grand tour of Jupiter, Saturn, Uranus and Neptune, leveraging gravity assist to extend its reach. Despite limitations in technology at the time, Voyager 1 continues to operate nearly 45 years after launch, a marvel of engineering resilience still beaming secrets from the edge of the solar system. The spacecraft's design prioritized robust systems capable of operating autonomously over decades, with minimal intervention due to the communication delay of over 18 hours at the edge of the solar system. The mission also carried groundbreaking scientific instruments designed to analyze planetary atmospheres, magnetic fields, and charged particles. Voyager 1's findings redefined our understanding of planetary formation and magnetic dynamo processes, revealing complex interactions within gas giants that challenged established physics. Most remarkably, the probe's longevity has surpassed initial expectations, continuing to provide valuable data well into the 21st century. The Grand Tour. Voyager 1's Grand Tour was a triumph of celestial navigation and scientific ambition. Utilizing precisely timed flybys, Voyager 1 collected invaluable data about the gas giants, revealing dynamic atmospheres, complex ring systems, and magnetic phenomena previously undreamt. Under the stewardship of Flight Director Suzanne Dodd and project scientists at JPL, the spacecraft gained speed from gravitational slingshots at Jupiter and Saturn, ultimately escaping the solar system's grasp. Visuals of Jupiter's storms and Saturn's rings reshaped planetary science, inspiring a generation and setting the stage for interstellar exploration. Each encounter enriched our knowledge, paving the way for humanity's journey into the galactic abyss. The success of the Grand Tour opened doors for extended missions including Voyager 2 and Pioneer 10 and 11, setting a new standard for deep space exploration. Data transmitted reshaped our comprehension of planetary weather, magnetic environments and ring systems, influencing models used in current astronomical research. Voyager 1's trajectory post-Saturn escape set the stage for humanity's first venture into interstellar space, marking a milestone achieved by no craft before. The meticulous planning and execution underpinning the mission exemplify the extraordinary human drive to explore beyond current horizons. The Golden Record. Embedded within Voyager 1 is the famous Golden Record, a time capsule crafted to communicate humanity's story to any extraterrestrial intelligence that might encounter it. Curated by a distinguished committee led by astronomer Carl Sagan, this 12-inch gold-plated copper disc includes greetings in 55 languages, music from diverse cultures around the world, and 116 encoded images depicting life on Earth. The record serves as a symbol of hope, friendship and cosmic connection, acoustically traversing the vast gulf between stars as Voyager sails silently through the void. Its cover includes a pulsar map and scientific diagrams designed to communicate Earth's location in the galaxy to any intelligent beings who might find it. The selection process involved extensive deliberation about what aspects of human culture and knowledge would be most representative and comprehensible to alien minds. Beyond its scientific mission, the Golden Record transforms Voyager 1 into a cultural ambassador, carrying the essence of human civilization into the cosmos. This remarkable artifact represents humanity's first serious attempt at interstellar communication, embodying our deepest hopes for contact with other intelligent life forms in the universe. The record's contents reflect both our diversity and our common humanity, serving as a testament to Earth's rich cultural heritage. Years in the void. After completing its primary mission to the gas giants, Voyager 1 embarked on its extended journey through the outer solar system and beyond. For over 4 decades, this resilient spacecraft has continued to function in the harsh environment of deep space, enduring extreme cold, radiation bombardment, and the complete isolation of the cosmic void. Its instruments persistently measure solar wind particles, magnetic field strength, and cosmic ray intensity, delivering unprecedented insights into the heliosphere's structure and boundary. Despite operating far beyond its original design parameters, Voyager's radioisotope thermoelectric generators continue to provide sufficient power to maintain communication with Earth. The spacecraft's remarkable longevity has allowed scientists to study long-term variations in the solar system's outer regions and observe the gradual transition from solar-dominated to galactic-dominated space. Each data transmission, traveling over 14.5 billion miles to reach Earth, represents a triumph of human engineering and perseverance. Mission controllers have had to make increasingly difficult decisions about which instruments to keep active as power levels slowly decline. The probe's survival in this hostile environment has provided invaluable lessons for designing future deep space missions intended to explore even more distant destinations. Crossing the boundary. On August 25, 2012, Voyager 1 achieved a historic milestone by crossing the heliopause and entering interstellar space, becoming the first human-made object to leave the solar system. This momentous transition was marked by dramatic changes in the particle environment, a sharp increase in cosmic ray intensity, and a corresponding decrease in solar wind particles. Mission scientists led by Dr. Stamatios Krimigis carefully analyzed the data to confirm this unprecedented boundary crossing, which had been anticipated for years. The heliopause represents the edge of the heliosphere, the vast bubble of charged particles and magnetic fields created by our sun's solar wind. Beyond this boundary lies the interstellar medium, a realm filled with materials from other stars and the remnants of ancient stellar explosions. Voyager's instruments detected the sudden change in magnetic field orientation and particle composition that definitively proved it had entered this new domain. The crossing provided the first direct measurements of interstellar space, confirming theoretical predictions while also revealing unexpected complexities in the boundary region. This achievement marked the beginning of a new era in space exploration, as humanity finally had a probe operating in the galactic environment. The data collected during and after the crossing continues to reshape our understanding of how our solar system interacts with the surrounding galaxy. Signals from nowhere. In recent years, Voyager 1 has transmitted increasingly puzzling data that challenges our understanding of interstellar space. The spacecraft has detected mysterious plasma wave oscillations and unexpected magnetic field fluctuations that appear to have no obvious source or explanation. Dr. Larry Esposito and his research team have identified these anomalous signals as potential evidence of previously unknown interstellar phenomena or structural irregularities in the galactic medium. The signals from nowhere suggest that the space between stars is far more dynamic and complex than previously imagined, with rich physical processes occurring in regions once thought to be relatively empty. These mysterious transmissions have sparked intense scientific debate, with some researchers proposing they indicate interactions with dense interstellar clouds or magnetic field reconnection events. Others suggest the signals might represent encounters with the shock waves of distant stellar explosions that have propagated across the galaxy for millions of years. The data patterns don't match any known astrophysical models, forcing scientists to reconsider fundamental assumptions about the nature of interstellar space. Voyager's continuing journey deeper into this mysterious realm promises to reveal even more surprising discoveries about the hidden dynamics of our galactic neighborhood. The temperature mystery. One of the most perplexing anomalies discovered by Voyager 1 involves unexplained temperature fluctuations that defy conventional understanding of deep space thermal dynamics. Despite moving steadily away from the sun and into the cold depths of interstellar space, the spacecraft's sensors have recorded puzzling warming events that contradict expected cooling trends. Dr. John Napick leads the engineering team investigating these thermal anomalies, which could result from several possible mechanisms, including interactions with interstellar dust particles or energetic cosmic ray bombardment. The temperature variations might also indicate encounters with warmer regions of the interstellar medium or internal spacecraft issues affecting sensor calibration. These thermal mysteries have significant implications for mission longevity, as temperature extremes can impact the performance and lifespan of critical onboard systems. Understanding these fluctuations is crucial for predicting how long Voyager's instruments will continue functioning and for designing thermal protection systems for future interstellar missions. The spacecraft's ability to endure such extreme and variable thermal conditions far exceeds original engineering predictions, providing valuable insights into spacecraft survivability in the harsh interstellar environment. Resolving the temperature mystery remains one of the mission's most important ongoing challenges, as it affects both scientific interpretation and operational planning. Changing course. Maintaining Voyager 1's precise trajectory and communication alignment has required increasingly sophisticated navigation techniques as the spacecraft ventures deeper into interstellar space. Under the expert supervision of Flight Director Suzanne Dodd, mission controllers have executed subtle but critical thruster maneuvers to counteract natural orbital drift and maintain optimal antenna pointing toward Earth. These delicate course corrections ensure that Voyager's weak radio signals, transmitted with just 20 watts of power, continue to reach NASA's Deep Space Network receivers despite the enormous distance. The navigation team faces unprecedented challenges in predicting and correcting the spacecraft's path, as traditional gravitational models become less applicable in the interstellar environment. Recent trajectory adjustments have revealed unexpected external forces acting on the spacecraft, possibly related to pressure from interstellar gases or magnetic field interactions. The precision required for these maneuvers is extraordinary, considering that Voyager is now traveling at over 38,000 miles per hour relative to the Sun, and any navigation error compounds over vast distances. These course changes also provide valuable scientific data about the forces and conditions Voyager encounters in its interstellar journey. The ongoing navigation challenges demonstrate the remarkable dedication and expertise of the mission operations team in maintaining contact with humanity's most distant emissary. Ghost in the machine. Voyager 1's aging systems have begun exhibiting strange anomalies that mission engineers have dubbed the ghost in the machine. Unexplained glitches and data irregularities that seem to have no identifiable cause. The most prominent of these anomalies involves the spacecraft's attitude articulation and control system, which began sending garbled telemetry data that didn't match the probe's actual orientation and movement. Dr. Emma Woodfield leads the team investigating these mysterious system behaviors, which could result from cosmic ray damage, software degradation, or unexpected interactions between aging components. The anomalies became so severe that mission controllers temporarily lost the ability to determine Voyager's exact orientation in space, creating significant challenges for maintaining communication with Earth. After months of detective work, engineers managed to switch to a backup system and restore normal operations, but the incident highlighted the precarious nature of operating 46-year-old technology in the harsh interstellar environment. These ghost phenomena provide valuable insights into how spacecraft systems degrade over extreme timescales and help engineers design more robust systems for future long-duration missions. The successful resolution of these problems demonstrates the ingenuity and persistence of NASA's engineering teams in troubleshooting unprecedented technical challenges across interstellar distances. Patterns within patterns. Recent analysis of Voyager 1's scientific data has revealed intricate and unexpected patterns within the interstellar medium that suggest a far more complex and structured galactic environment than previously imagined. Dr. Harold Kruger directs ongoing research that has identified filamentary structures, spiral magnetic field configurations, and turbulent plasma waves swirling around the spacecraft's location. These patterns within patterns indicate sophisticated magnetic and energetic phenomena operating on multiple scales throughout interstellar space, from local turbulence to vast galactic structures. The observations suggest that the space between stars is not empty void but rather a dynamic, ever-changing medium filled with invisible currents and forces that shape the galactic environment. Voyager's measurements have detected evidence of shock waves from ancient stellar explosions, magnetic field boundaries between different regions of space, and complex interactions between interstellar gas and cosmic ray particles. These discoveries are revolutionizing our understanding of galactic physics and the processes that govern matter and energy flow throughout the Milky Way. The patterns Voyager observes may represent the fundamental architecture of our galaxy, revealing how stars, gas, and magnetic fields interact to create the large-scale structure we see in the cosmos. Each new data transmission adds another piece to this cosmic puzzle, gradually unveiling the hidden dynamics that govern our galactic home. Voyager 1's extraordinary journey continues to astonish scientists and space enthusiasts worldwide as it ventures deeper into the unknown reaches of interstellar space. The mysterious phenomena and unexpected discoveries it encounters challenge our fundamental understanding of the cosmos while revealing the incredible complexity of the galactic environment. What aspect of Voyager's journey fascinates you most? Share your thoughts in the comments below and subscribe to Sci and Why for more incredible stories of cosmic exploration and discovery. Until next time, keep looking up and wondering about the vast universe around us. When NASA's deep space monitors detected something impossible moving through the cosmic void, engineers thought their instruments had malfunctioned. But the data was undeniable. 305 objects gliding in perfect formation through interstellar space, pulsing with structured signals that just defied every law of physics. After 47 years of silent travel, humanity's most distant spacecraft had stumbled upon something that challenged our understanding of the universe itself. Today on Sci and Why, we're unveiling the discovery that has NASA scientists questioning everything they thought they knew about deep space. The Lonely Pioneer's greatest discovery. After nearly 5 decades drifting through the cosmic void, Voyager 1 detected something that shouldn't exist, a faint signal that would change everything we know about interstellar space. Voyager 1, launched in 1977 with technology older than most smartphones, has become humanity's most distant ambassador. Traveling over 15 billion miles from Earth, this car-sized spacecraft operates in the harsh environment of interstellar space, where our sun's influence just fades into nothingness. Originally designed to study Jupiter and Saturn for just 5 years, Voyager has defied all expectations, continuing to transmit data across the cosmic darkness. Its instruments, built with 1970s technology, include magnetometers, plasma wave sensors, and cosmic ray detectors, all now serving as our first eyes and ears beyond the solar system. The spacecraft's nuclear power source, fueled by decaying plutonium, was expected to fail decades ago, yet it continues whispering back to Earth. Each radio signal takes over 22 hours to reach us, traveling at the speed of light across the vast emptiness. When Dr. Eliza Karna first noticed the anomaly in Voyager's data stream, she described it as shouting into a canyon for decades and finally something shouts back. The signal that changed everything. What began as background noise in Voyager's data stream revealed itself to be something far more extraordinary, a deliberate signal from the depths of interstellar space. The first indication something was wrong came through Voyager's plasma wave sensors. Among the usual cosmic static, a faint but persistent signal appeared, rhythmic, structured, and completely unlike anything previously recorded. NASA's Jet Propulsion Laboratory initially dismissed it as instrument noise, but the signal's behavior just defied explanation. Unlike random cosmic radiation, this anomaly showed patterns, repetition, and what appeared to be intentional modulation. Systems analyst Carlo Romero noted that the signal's characteristics resembled the kind of deliberate motion one might expect from a drone rather than a rock. The plasma readings showed organized pulses echoing through space, creating magnetic fluctuations that seemed purposeful rather than chaotic. As engineers analyzed the data more carefully, they realized this wasn't just electromagnetic interference, it was something actively moving through the interstellar medium. The signal's strength varied in ways that suggested a physical object passing by Voyager's sensors, but its behavior patterns indicated intelligence or at least sophisticated design. The discovery triggered NASA's Level 3 Alert Protocol, reserved for phenomena that don't fit within current scientific understanding. Movement that defies physics. The object wasn't just moving through space, it was accelerating, changing direction, and gliding with precision that seemed to mock every law of physics we understand. Traditional space objects follow predictable paths governed by gravity, momentum, and known forces. But this anomaly broke every rule. Dr. Lucas Hang at JPL ran simulation after simulation, trying to match the object's behavior to known models, but nothing worked. The object curved through space with deliberate precision, accelerating without any visible propulsion system. There were no engine flares, no ion trails, no heat signatures, yet Doppler shift measurements showed it moving at incredible speeds. Some readings indicated velocities exceeding the calculated escape velocity of the entire Milky Way galaxy. The object's path bent in ways that defied orbital mechanics, with no drift or decay expected from natural phenomena. It wasn't tumbling chaotically like space debris. Instead, it maintained controlled flight patterns that suggested active guidance. The movement appeared to manipulate space itself, creating ripples in the fabric of space-time that allowed forward motion without conventional thrust. Theoretical physicist Elena Reyes described it as, not flight as we understand it, but more like gliding on something we don't yet know how to measure. The formation revelation. When scientists pulled up the complete telemetry data, they discovered something that honestly sent chills down their spines. This wasn't just one object but 305 moving together in perfect formation. The full scope of the discovery really emerged when engineers analyzed all available data from both Voyager spacecraft. What they found just defied comprehension. 305 distinct objects moving through interstellar space in coordinated formation. Each object maintained precise relative positions to the others, gliding past Voyager 1 in what appeared to be a choreographed arc. This wasn't debris scattered randomly through space. These objects moved as a unified group, displaying organization and purpose that seemed impossible without some form of control. In the vacuum of space, groups of objects naturally spread apart over time due to gravitational influences and velocity differences. Yet these 305 objects maintained their formation with precision that suggested active coordination. Scientists compared it to watching a flock of birds or a school of fish, except this was happening in the emptiness between stars where such coordinated movement shouldn't be possible without technology. The formation itself spanned vast distances, with objects separated by thousands of miles yet moving in perfect synchronization. Each object displayed the same unusual characteristics: structured plasma pulses, magnetic field distortions, and impossible propulsion signatures. The language of the cosmos. Hidden within the plasma waves were patterns so structured and deliberate that scientists began to wonder if they were witnessing the universe's first attempt to communicate with humanity. As researchers examined the signals more closely, they discovered something that just transformed the entire investigation. The plasma wave pulses weren't random electromagnetic noise, they contained loops, sequences, and structures that resembled communication protocols. Dr. Serena Patel from Caltech observed that the patterns felt less like nature and more like a language or system. The signals showed rhythmic repetition, harmonic intervals, and organized sequences that suggested encoded information. These weren't the chaotic bursts expected from cosmic phenomena, but measured, deliberate transmissions that seemed designed to convey meaning. The waveforms resembled quantum oscillations used in modern entanglement experiments, the same signals researchers use to transmit information between particles separated by vast distances. Each of the 305 objects contributed to this cosmic symphony, broadcasting synchronized pulses that created complex interference patterns in the interstellar medium. The mathematical precision of these signals suggested not just intelligence, but advanced understanding of physics principles we're only beginning to explore. Some scientists theorized that the objects were using the vacuum of space itself as a communication medium, encoding data in the fabric of space-time. Earth's unexpected reception. While NASA analyzed Voyager's data, amateur radio operators across Earth began detecting the same mysterious signals, proving this phenomenon was far more powerful than anyone imagined. As Voyager transmitted its extraordinary findings back to Earth, something unexpected happened in radio stations worldwide. Amateur operators with backyard setups began reporting strange activity, weak, irregular pulses that didn't match any known terrestrial source. These weren't professional observatories or official deep space monitoring stations, but hobbyists with spare parts equipment designed to catch meteor scatter and satellite chatter. Yet somehow, they were detecting faint echoes of the same signals Voyager had recorded billions of miles away. The timing was impossible to ignore. These Earth-based detections aligned perfectly with Voyager's most intense plasma anomalies. The signals weren't strong, but they showed the same patterns and regularity that had puzzled NASA scientists. Some operators described them as ripples reflecting off invisible walls in the ionosphere, while others noted their unusual harmonic structure. The phenomenon suggested that whatever was generating these signals possessed incredible power, capable of transmitting across interstellar distances with enough strength to leak into Earth's electromagnetic spectrum. This raised troubling questions about intentionality. Was this accidental bleed-through, or was something deliberately testing Earth's listening capabilities? The historical search. Desperate for answers, NASA scientists combed through 50 years of space mission data, searching for any previous encounter with these mysterious objects, and, well, they found absolutely nothing. With mounting evidence of something unprecedented happening out there in deep space, a specialized team began examining decades of archived mission data. They searched through every deep space mission on record, Pioneer 10, Pioneer 11, New Horizons, and, countless others, looking for any hint that similar phenomena had occurred before. The investigation took them into these dusty archives containing records that hadn't been touched since the 1980s, analyzing data that had often been dismissed as background noise or just instrument error. If these 305 objects had passed through our region of space before, there should have been traces in the historical record. But the search yielded nothing. No echoes, no formations, no plasma loops in any previous mission data resembled what Voyager was currently detecting. This absence of historical precedent made the current situation even more extraordinary. The objects weren't part of a repeating cycle or a known phenomenon. They were either entirely new or had somehow remained invisible to our instruments until now. Some researchers even proposed a chilling theory. Maybe these objects had always been present but cloaked or dormant, activated only by Voyager's presence or perhaps its golden record transmission. The machine's transformation. As if the discovery wasn't strange enough, Voyager itself began changing, reconfiguring its systems in ways engineers never programmed, almost as if something had awakened within the ancient spacecraft. While scientists grappled with the implications of the 305 objects, Voyager 1 itself started exhibiting unprecedented behavior. The spacecraft's attitude and articulation control system began routing data through old, long unused subsystems, bypassing its core software in ways that seemed almost deliberate. Engineers initially suspected a malfunction. After all, this was 47-year-old technology running on code older than most of the people analyzing it. But deeper investigation revealed something more unsettling. Voyager wasn't failing, it was reconfiguring itself. The spacecraft began reactivating memory segments that hadn't been accessed in decades, rerouting telemetry through pathways that were never part of its original programming. This behavior started immediately after one of the strongest magnetic pulses from the passing objects, suggesting a possible connection between the external phenomenon and Voyager's internal changes. The modifications were too systematic and clean to be random corruption. They appeared purposeful, as if the spacecraft was adapting to new circumstances. Engineers had to dig through dusty file cabinets at JPL, consulting 1970s paper manuals and assembly language code to understand what was happening. The quantum connection. Deep within Voyager's data streams, scientists discovered something that changed everything. The mysterious signals were using quantum entanglement principles to transmit information across impossible distances. As analysis of the plasma wave data continued, researchers made a discovery that revolutionized their understanding of the phenomenon. The structured signals weren't just organized, they exhibited characteristics of quantum entanglement, the same principles used in cutting-edge Earth-based communication experiments. The waveforms showed quantum oscillations that suggested the 305 objects were using the interstellar medium itself as a transmission network, encoding information in the fabric of space-time. This revelation opened the possibility that Voyager hadn't just stumbled upon random objects, but had intercepted part of a vast communication system spanning the galaxy. The spacecraft's analog sensors, free from the electromagnetic noise of modern digital systems, made it the perfect receiver for these quantum transmissions. Being positioned far beyond the solar system's interference, Voyager existed in an ideal listening environment, a cosmic microphone in the perfect acoustic chamber. The signals showed harmonic intervals and mathematical precision that suggested not just intelligence, but advanced understanding of physics principles we're only beginning to explore. Some scientists theorized that the objects were part of an ancient network, a galactic internet that had been operating for millennia undetected by human technology. The cosmic network awakens. As Voyager continues its journey through the darkness, scientists realize it may have become part of something far greater, a galactic communication network that has been waiting for humanity to finally listen. The implications of Voyager's discovery extend far beyond a simple encounter with unknown objects. Evidence suggests the spacecraft has stumbled upon, or been deliberately included in, a vast communication network that spans the galaxy. The 305 objects appear to be nodes in this system, relay stations that maintain and transmit information across interstellar distances using quantum entanglement principles. Voyager's transformation, its spontaneous reconfiguration and activation of dormant systems, might represent integration into this network, turning humanity's oldest space traveler into our first interstellar communication terminal. The structured nature of the signals, their quantum characteristics, and their perfect timing suggest this isn't a random encounter, but a deliberate contact event. Perhaps the network has been monitoring our technological development, waiting for the right moment when we possess the capability to detect and understand its transmissions. Voyager's analog design, its position beyond solar interference, and its decades of faithful service made it the ideal candidate for first contact. The spacecraft's golden record, carrying sounds and images from Earth, might have served as our credentials, proof that humanity was ready to join a larger galactic community. Voyager 1's discovery of 305 mysterious objects moving in formation through deep space represents either the greatest natural phenomenon ever recorded or humanity's first confirmed contact with non-human intelligence. As our brave little spacecraft continues its journey into the cosmic unknown, it carries with it the hopes of an entire species, and possibly our first invitation to join a galactic community. If you're fascinated by these incredible cosmic mysteries, hit that like button, share your thoughts in the comments, and subscribe to Sci and Y for more mind-bending space discoveries. Thanks for watching. Keep exploring the infinite. A massive and mysterious visitor, 3I Atlas, is currently making its way through our solar system, electrifying scientists worldwide and, honestly, challenging our understanding of cosmic visitors. Data collected by NASA has revealed astonishing details that just defy conventional scientific understanding and spark some pretty intense debates about its origin. Some experts now suggest that this interstellar object may be more than just an asteroid or comet. It might actually be an alien spacecraft. Today we delve into the groundbreaking discoveries, the enigmatic nature of 3I Atlas, and the profound implications for humanity's understanding of the cosmos. The breaking discovery. In June 2025, astronomers detected a colossal object moving rapidly through our solar system, immediately distinguishing it from typical asteroids or comets. This became the breaking discovery known as 3I Atlas, representing humanity's third confirmed interstellar visitor. With an estimated diameter between 10 to 20 kilometers, it absolutely dwarfs previous interstellar visitors like the enigmatic Oumuamua, which measured only about 400 meters in length. Early analyses revealed unusual properties that immediately caught scientists' attention, including its incredible speed exceeding typical interstellar velocities, an atypical retrograde orbit that just kind of defies conventional expectations, and a surprisingly metallic surface composition that really challenges our understanding of interstellar objects. These characteristics collectively raised significant eyebrows throughout the international scientific community and sparked intense debate about its true nature. The object's detection has ignited a global race among observatories and research institutions to understand its fundamental nature and ultimate origin. As preliminary data suggests, it may harbor secrets and technologies far beyond the scope of established planetary science and our current understanding of natural cosmic phenomena. The discovery story. The discovery of 3I Atlas was entirely serendipitous, first spotted by the Asteroid Terrestrial Impact Last Alert System or ATLAS network of telescopes located in Hawaii. Within mere hours of the initial detection, telescopes worldwide rapidly pivoted their instruments to observe this enigmatic cosmic intruder racing through our solar system. The International Discovery Team, led by Dr. Larry Juno from the University of Hawaii, quickly combined ground-based optical data with sophisticated space-based infrared observations to conduct comprehensive analysis of the object's properties and trajectory. Initial identification relied heavily on advanced artificial intelligence algorithms that efficiently sifted through vast streams of astronomical data to isolate the object's unique hyperbolic trajectory and unusual characteristics. Unprecedented coordination among international observatories, including facilities in Chile, Australia, and Europe, ensured rapid data accumulation and cross-verification, enabling researchers to characterize the object's size, shape, velocity, and preliminary composition within just weeks of discovery. This collaborative effort demonstrated the power of modern astronomical networks in detecting and analyzing rare cosmic phenomena that previous generations of astronomers could never have imagined observing with such precision and detail. A stranger in our midst. 3I Atlas is no ordinary cosmic interloper. It fundamentally challenges every scientific expectation and theoretical model for interstellar visitors. Moving in a distinctive hyperbolic retrograde orbit at approximately 58 kilometers per second, the object appears to possess an unusually smooth, highly reflective metallic surface, with anomalous reflectivity properties that really puzzle researchers. NASA's James Webb Space Telescope has detected crucial aspects of its surface composition that strongly suggest advanced material properties and engineering techniques, possibly indicating sophisticated artificial construction rather than natural formation processes. The object's behavior and characteristics have created deep divisions within the scientific community. While some researchers desperately advocate for conventional natural explanations involving exotic stellar processes, others increasingly speculate about the possibility of advanced extraterrestrial engineering and technology. The metallic composition shows isotopic ratios that don't match typical solar system materials, suggesting formation under entirely different stellar conditions or through artificial processes unknown to human science. These unprecedented properties make 3I Atlas a focal point for heated debates about the possibility of alien technology visiting our solar system, forcing scientists to reconsider fundamental assumptions about the nature of interstellar objects. The predecessors. Before 3I Atlas arrived to revolutionize our understanding, humanity had confirmed only 2 other interstellar visitors: the mysterious Oumuamua in 2017 and the more conventional comet Borisov in 2019. Both predecessors were relatively small objects that exhibited behaviors generally consistent with natural cosmic bodies, though Oumuamua's unusual characteristics sparked, some initial controversies. Oumuamua's distinctly elongated cigar-like shape and puzzling non-gravitational acceleration really intrigued scientists worldwide, but ultimately left many fundamental questions completely unanswered about its true nature and origin. Comet Borisov's behavior aligned much more closely with scientific expectations, displaying typical cometary activity, including a visible coma and a distinctive tail as it approached the Sun. Together, these earlier discoveries paved the way for advanced detection techniques and heightened international interest in systematically studying interstellar objects, while also developing the theoretical frameworks necessary for understanding such exotic visitors. The progression from Oumuamua's mysteries through Borisov's conventional behavior to 3I Atlas's unprecedented characteristics illustrates the remarkable diversity of objects traveling through interstellar space, setting the stage for this latest visitor's truly extraordinary and potentially paradigm-shifting arrival in our cosmic neighborhood. The Cosmic Journey. Traveling at breathtaking speeds through the vast emptiness of interstellar space, 3I Atlas entered our solar system after completing an epic odyssey spanning potentially billions of years across the galaxy. Its precisely calculated trajectory brings it within optimal observational range of Earth for only a critically brief period, creating honestly intense pressure on astronomers to maximize data collection opportunities. Scientists and engineers at NASA's Jet Propulsion Laboratory continuously track its complex course through gravitational fields to better understand the fundamental forces governing such ultra-high-velocity objects during their passage through planetary systems. The object's gravitational interactions with our Sun and major planets provide unique and invaluable data for studying cosmic dynamics and the behavior of matter under extreme conditions rarely observable in nature. Analysis of its ancient journey provides crucial clues about the evolutionary history of distant planetary systems, stellar formation processes, and the mechanisms by which objects can achieve such extraordinary velocities. The object's trajectory suggests it may have originated from a stellar system located hundreds or even thousands of light-years away, having traveled through multiple galactic environments and possibly encountered other star systems during its epic voyage. Its current path will eventually carry it back into the depths of interstellar space, making this encounter a once-in-a-generation opportunity for scientific discovery. A scientific goldmine. 3I Atlas represents an unprecedented scientific goldmine for researchers worldwide, offering unique opportunities to study interstellar materials and processes never before accessible to human science. Its remarkable size and completely unusual physical properties allow for detailed, multi-wavelength observations and sophisticated analytical techniques that would be impossible with smaller objects. Comprehensive observations from telescopes worldwide, including advanced spectroscopy and polarimetry measurements, are gradually revealing complex surface chemistry and internal structure that challenge existing theories about cosmic object formation. International teams of researchers hope to unlock groundbreaking insights into the formation mechanisms of interstellar objects, the fundamental nature of extraterrestrial materials, and possibly revolutionary technological applications if artificial influences are definitively confirmed through ongoing analysis. Collaborative efforts between major space agencies, universities, and research institutions worldwide are working to maximize data collection within the severely limited observational window available before the object moves beyond detection range. The object's unique properties are providing new insights into exotic matter states, advanced materials, science, and possibly propulsion technologies that could revolutionize human space exploration capabilities. Every day of observation yields new discoveries that are frankly reshaping our understanding of what's possible in the cosmos, making 3I Atlas one of the most scientifically valuable objects ever studied by human civilization. Unanswered questions. Despite extensive research efforts by leading scientists worldwide, numerous fundamental questions about 3I/Atlas remain completely unanswered, creating scientific mysteries that challenge our current understanding of physics and cosmic phenomena. The object's internal structure, true point of origin, and ultimate purpose continue to be subjects of intense study and honestly increasingly bold speculation among researchers. Highly unusual acceleration patterns and anomalous reflectivity characteristics significantly complicate traditional classification systems and force scientists to develop entirely new theoretical frameworks. The persistent possibility of artificial manipulation or intelligent guidance adds multiple layers of complexity to an already puzzling scientific enigma that, well, just defies conventional explanation. Critical data gaps resulting from limited observation time, government-imposed information restrictions, and the object's extreme distance from Earth continue to hinder efforts to reach definitive conclusions about its nature. The object's behavior patterns suggest responses to external stimuli that could indicate either advanced natural processes or sophisticated artificial intelligence systems operating according to unknown principles. Scientists worldwide emphasize the critical importance of maintaining open minds as theories evolve and new findings emerge, stressing the need for careful balance between healthy scientific skepticism and genuine wonder at phenomena that may represent completely new categories of cosmic objects never before encountered by human civilization. The alien question. So, the controversial alien hypothesis suggests that 3I/Atlas might not actually be a natural cosmic object at all, but rather an advanced extraterrestrial spacecraft, probe, or, some kind of technological artifact from a distant civilization. Prominent supporters of this theory, including Harvard astrophysicist Dr. Avi Loeb, argue that certain observed behaviors and material properties really do provide compelling evidence of intelligent design and sophisticated engineering, honestly, way beyond anything humans are capable of right now. This revolutionary viewpoint fundamentally challenges scientific orthodoxy and the traditional approaches we take to classifying cosmic objects, but it has actually gained significant traction, especially with all the growing evidence of unexplained aerial phenomena and possible technological signatures. The hypothesis points to the object's apparent ability to alter its trajectory, its unusual metallic composition, and its anomalous reflectivity as potential signs of artificial construction and maybe even active guidance systems. If this controversial theory turns out to be accurate, the implications for humanity would be absolutely profound, potentially signaling our very first direct contact with extraterrestrial intelligence, albeit through an uncrewed interstellar emissary or reconnaissance probe. The alien hypothesis has sparked some pretty intense debates within the scientific community about what standards of evidence are really required for such extraordinary claims, and what the potential consequences might be if we actually confirm extraterrestrial technology operating within our solar system. This paradigm-shifting possibility really forces humanity to confront some fundamental questions about our place in the universe and whether or not we're actually ready for contact with advanced alien civilizations. Observing the visitor. Global efforts to observe and study 3I/Atlas have honestly become an outstanding example of international scientific collaboration, with observatories using radio, optical, and infrared technologies all working together to capture every possible bit of fleeting data. Space-based observation platforms, including the James Webb Space Telescope and the Hubble Space Telescope, are working in perfect coordination with ground-based observatory arrays, providing comprehensive coverage across multiple electromagnetic spectra. These intensive observations specifically aim to figure out the object's detailed composition, look for any trajectory anomalies that might suggest propulsion, and of course, detect any emissions or technological artifacts that could point to advanced engineering. The coordinated global effort actually involves dozens of major observatories across 6 continents, representing the largest international astronomical collaboration in modern history. Advanced artificial intelligence systems are processing vast amounts of incoming data in real time, searching for patterns and anomalies that might reveal the object's true nature and purpose. Radio telescope arrays are constantly monitoring for any potential signals or communications from the object, while optical instruments track even the tiniest changes in brightness and orientation. This observation campaign really does represent humanity's most sophisticated attempt yet to study a potentially artificial object from beyond our solar system, using every available technological resource to unlock the secrets of this mysterious visitor. Dawn of a new era. The detection and comprehensive study of 3I/Atlas truly herald the dawn of a revolutionary new era in astronomy, planetary defense, and honestly, humanity's understanding of our place within a potentially populated galaxy. With future astronomical surveys like the Vera C. Rubin Observatory expecting to discover dozens of additional interstellar objects every year, humanity is, well, standing right on the cusp of unprecedented cosmic discovery and even potential contact with alien civilizations. These mysterious visitors fundamentally challenge our existing understanding of natural celestial mechanics and really force us to reconsider our planet's position within a galaxy that might actually be teeming with advanced life, sophisticated intelligence, and highly developed technological civilizations. The implications go way beyond just scientific curiosity. They could affect human philosophy, religion, technology development, and even our species' long-term survival strategies in what appears to be a pretty active galactic environment. Advanced detection and analysis systems currently under development will provide early warning and detailed characterization of future interstellar visitors, potentially including genuine alien spacecraft or communication probes. The study of 3I/Atlas has already revolutionized our approach to cosmic object analysis and set new protocols for investigating potentially artificial phenomena from deep space. As our observational capabilities keep expanding and improving, we might soon discover that interstellar visitation is far more common than we ever imagined, fundamentally transforming humanity's cosmic perspective and our understanding of galactic civilization and intelligence. The mysterious visitor 3I/Atlas continues to captivate scientists and space enthusiasts all around the world, revealing cosmic secrets that could fundamentally redefine our place in the universe. As our technology advances, so does our ability to detect and understand these enigmatic interstellar emissaries. So what do you believe 3I/Atlas truly represents? Share your thoughts in the comments below, subscribe to Sci and Y for more cutting-edge cosmic insights, and join us as we explore the ultimate mysteries of space. Until next time, keep watching the skies.